Today we're going to be talking about congruence transformations. Congruence transformations have a couple of names. Congruence transformation is one. A rigid transformation is another. And the reason that they're called this is because we're going to change the position of the object or the shape, but we're not actually going to change the size. Not all transformations are like this. There are other transformations that do change the size or even change the shape of a figure, and we're not dealing with those at this point. This time we are only talking about transformations that change the position or the location of a shape, not its size and not its shape. Okay? And that's part of why they're called congruence transformations, because your beginning shape and your ending shape are both going to be congruent figures. So that's going to be really important. Another term you might hear in relation to these is called an isometry. I'm just going to spell that out here. And that is just another term for a congruence transformation. We just have three names here. Right? So let's talk about some terms that we're going to need. We're going to be dealing with multiple shapes, okay? And some of them are going to be our beginning shapes, and some are going to be our shapes after they have been transformed. And so we want to be sure that we can identify which one came first and which one came second, or third, or fourth. And so when you draw these, you obviously know which one you drew first or second, but somebody else can't necessarily tell that. And so we have some terms for these. So the first image is going to be called the pre-image. So it's the image before we did anything. That's why it's called the pre-image. After we have transformed that figure, the new picture is called the image. Okay, so pre-image came first, the image comes second. Another way you're going to be able to tell the difference in which one came first and which one came second is going to be in the name. So if I were to name this first triangle, it would be triangle ABC. When I create my second shape, for the name of the second image, we actually add an apostrophe next to each of these, and that's called in math a prime symbol. So when we write out the name of our second shape or image, this would be A prime, B prime, C prime. Okay? And the little prime, or the apostrophes for each of those, just tells us, hey, that's the second image. If we had a third image, if we did another transformation, right, and we wanted a third image here, then it would get 2 primes. So it would be A double prime, B double prime, and C double prime. So that's just going to tell us, where we are in the progression of this shape. All right? Okay, so now we're ready to talk about our 3 major types of transformations. The first one is a reflection. Okay? And the reflection is going to work just like you might expect it to, like a mirror might work. All right? So if I had a shape, and in your book they use the triangles, but I'm actually going to use the letter E because I think it's a little bit easier to picture the transformation. If I have the letter E here, and I want to reflect it, okay, it's got to be reflected across a line. So this is my line of reflection, or the line which it was reflected across. And so just like in a mirror, if you ever hold something with words up to a mirror, you might have done this as a child for like some of the silly games or silly books where you have to find out the answer. You have to either have a red piece of plastic or you have to hold it up to a mirror or something like that. They use it for codes. Same kind of idea here. When you do that, then it flips the image around. And so this is also when you were a child or you were in a lower grade level, this might have been referred to as a flip. Okay? So when we do that, you're going to notice that the shape is flipped around. Okay? And so here we have this point, right, and this point are both an equal distance from our line of reflection. So if I was measuring from here to this line of reflection and it's 3 units here, then guess what? Over here it's going to be 3 units as well. If the measurement from this point to the line of reflection is 3 units, then that means that from this point to this line of reflection is 3 units. Okay? And then the same thing for our center point here. And so it's really nice that it works this way because it means that when we graph these, we're going to be able to figure out what our new image looks like, and we're going to be able to graph it really precisely. Okay, so that's going to be really handy. Our next transformation is called a translation. Okay, and just like when you translate from one language to another, when you're translating an image, you're just moving it from one place to another, right? So in languages, you go from one place to another, and you have to have a translator, or you have to translate because the because the language is different. When we're dealing with a translation for geometry, you are going to translate along a vector. Okay, so this would be your vector, and it's just telling you this is the direction and amount that I'm moving this shape. And so when you recreate it, it's exactly the same size, it's exactly the same shape, it's just moved. When we do this on a graph, we typically take one of the points, right, and we are going to want to graph that same point but in a new location. And so they will give you your information. They'll say, you need to move this shape down 6 and over to the right 15 units. Okay, and so you would do that with each of your points. So you would go down 6 and over to the right 15, and that would be from the first point. Then you do that from every point. Okay, and that would make it so that you had created or recreated your image in its new location, which is what you wanted to do. Right? You wanted to take your first shape and you wanted to move it from where it is to a new location. Right? And that will move the whole thing down 6 units and over 15. And they may give those to you as coordinates for a graph. They may give it to you as a vector that you have to measure. There's some different options that may show up on there. So we'll look at those a little bit later. Also, another term for this one would be a slide, because it just slid over. Our final transformation is a rotation. And I don't have another name for this one. I'm pretty sure that they just always call it a rotation. And so this is going to be like you attached a figure to the end of a spinner on a game, and you watched it move around, and so it was rotated. And so for a rotation, you're always going to have a center of rotation. This is my center of rotation. And this is the point around which it's moving. So if you imagine there is an imaginary line connected from here to my letter E. That's the figure we're working with at the moment. And so when I rotate my letter E, we'll say I'm rotating it clockwise here, okay? And I rotate it over here, you're going to notice that however long this invisible line is, we'll say it's like 5 units, it's going to be the same length when it stretches over here. It's still going to be 5 units, right? So some people expect that the center of rotation will always be the center of the object, and that's really a common misconception when you're dealing with something like a triangle. They think, oh, if it was here, then it's just turning, and so my new shape is going to be in exactly the same spot. It's just going to have turned some. And that is a possibility, but it's just not always the way it works. So you really have to be sure you can identify your center of rotation. Okay? And again, these are going to be each of your points on your figure will be the same distance from the center of rotation on the original shape and on your final shape. Last piece of information on this one. Rotations can either be clockwise or counterclockwise. Remember, it goes backwards, sorry. And so you just have to be sure you're paying attention. Some books automatically say, unless we're doing, unless it says otherwise, then it's always going to be clockwise, or unless it says otherwise, then it's always going to be counterclockwise. And I have not seen one of those pieces of, like, here, look at me kind of information, bullet points in your book this time. So just kind of be on the lookout, because it could be a rotation either clockwise or counterclockwise, and we'll deal with those a little bit more later on this year. I hope you have a wonderful afternoon. Thank you for watching, and I will see you tomorrow.